Good afternoon, everybody. My name is Jenny Wang, and I'm from the Big Data team in Intel. And my other colleague, Yiheng Wang, is also here today. And today, I want to share some experience of building the deep learning-powered big data analytics using the BigDL. First, let's look at what's a BigDL. The BigDL is a distributed deep learning library on Apache Spark. It is directly on Spark, and it's a standalone library which can work with other Spark components like the Spark Cycle, Spark Streaming, and MLlib to create complex pipelines. You may be wondering why we create the BigDL. Let's look at some trends in recent years. First, you can look at the left diagram. As you know, with the data become much bigger and bigger, the larger neural network can show a very excellent advantage than the traditional machine learning algorithms. So the BigDL can be a very good tool to facilitate the deep learning algorithm. And also you can notice that in the reality, the production a machine learning or deep learning system is a very complex system. It contains a lot of components like the data collection, the feature extractions, and analytics tools, monitoring, etc. And the machine learning model is just a small black box in that ecosystem. As you know, the BigDL is based on the Spark, so it is very easy for BigDL to integrate with other Spark components to build a more complex Spark or Hadoop system. And in the last year, on the December 13th, we already open sourced the BigDL library. And because it's direct on the Spark, so you can write a program, a BigDL program, as a standard Spark program. And because it's run on the Spark or Hadoop clusters, so there's no need to change the clusters or to move the data from one cluster to another cluster. And also, the BigDL have the rich deep learning support. So let the user to create their own different kind of models or examples. And accelerated by the Intel MKL library, the BigDL program can achieve a very high performance, comparable performance as a program in the same generation GPU environment. With the all-reduced communications in the BigDL, the BigDL program can easily to scale out and efficiently on the Spark clusters. That's just a brief introduction of BigDL. We have another session which is on the 540. You can get more detailed information of design and implementations of BigDL in that session. Today's focus is on how to use the BigDL to write the use case and examples. First, I will show one pipeline example of fraud transaction detection. The fraud transaction detection is a very important requirement in the financial systems. And many financial companies use the machine learning solution to resolve this problem. But the machine learning solution faces some challenges like the data cleaning, the feature engineering, unbalanced data, and hyperparameters. We'll show our solution to resolve these challenges. Here's the pipeline for one of our customers. First, we have the historical data, such as the transaction records and the merchandise profiles, which is stored in the Hive. And then the field engineering will analyze with the domain knowledge to do the data cleaning and pre-processing with the Spark Cycle. And after that, we will use the Spark machine learning ML pipeline to do the feature engineering. And now we use the BigDL to write more than 10 different independent models. And we use the grid search to tuning the hyperparameters for these models. And we use the undersample and the bagging strategy with these models to improve the accuracy of the perception and the recalls. So that's one example to how to integrate with BigDL applications in the Spark pipeline. Here's another examples of the Spark pipeline using the BigDL. In this time, we need to do the product defect detection and the classifications. And our data set is images on the manufacturing pipelines. And our task is first, we need to detect the defects from the images. And then we need to classify the defects. Here's the solutions. We have a huge amount of high-resolution image as the input data. And we use the parallel proposal extraction, which running in the Keystone ML pipeline on the Spark to get the proposals. And then for the proposals, we use the preprocessing to process these images. And then we use BigDL to create the convolutional neural network. And also we tune the parameters and also do the optimizations of the proposal extractions. So after that, we can get a very good performance of defect detection and classifications. As you know, in the image recognition area, the object detection is a very popular field. And this is a different purpose for the with image classifications. So in that case, you can find different items in one image, like the birds, the dogs, and bicycles, and sofas, and airplanes. And for this object detection, there are many different frameworks. And the fast RCN is one of the popular detection frameworks. It shares the features between the detection framework and the region proposal network. In our examples, we already used the BigDL to implement the fast RCN, and we get a very good performance. Here's a code segment of how to use the BigDL to write such kind of fast RCN model. First, we create a fast RCN model, and then we passing the image folder to create the data set. And then we create a validator of the data set. And then we run the test with the validators and visualize the objects in the image folders. Besides the image recognition, the deep learning is also widely used in the natural network processing. So in our example, we also create a language model with RNN. Here's the pipeline. First, we use the sentence tokenizer to get the words, and then we create the dictionary, and then we do the transformations of the input document. And using this data, we train our RNN model. And after we got the model, we can generate sentences with some trigger words. Here's the output of the RNN model. Our data set is Shakespeare's corpus, and our learning can learn the styles of the corpus and generate a sentence. For example, if we input some trigger words like the long life the, and the model can generate the sentence king, the queen, and the stranger of the, and the blah, blah, blah. This sentence has a similar style of Shakespeare poems. So that's a model of the language model. And also the BigDL provide a functionality to load the cafe torch or the BigDL models. Using this function, we can fine-tune the different data sets with different purpose. For example, in this case, we loading the cafe ImageNet model and then we to our BigDL model, and then we fine-tune the models to predict the image style instead of the image type. And you can see after we use the fine-tune, the accuracy increased by 10% compared with the training from scratch, and also the converge time decreased. As you know, as I mentioned before, the BigDL need to play with other components in the Spark system. So we also have the example that's how the BigDL integrate with the Spark streaming to receive the messages from Kafka message system to do the runtime training and the prediction. And we will also have the BigDL can tightly integrate with the Spark Circle and the data frames. Here's an example. We have some pictures, and we create the user-defined function named image classifier. And that function can do the classifications of the image data frame and create a new column image type. And the user can query the images with the image type. He can select the images whose image type is dog and then output the dog images. We have many other BigDL examples. You can access our GitHub repository to get more help of how to write the models or examples with the BigDL. And for today and tomorrow, you can also go to our booth to get more support and information. And I hope BigDL can help developers to create their own models, examples, and pipelines on the Spark system. So I think that's all from today's presentation. Thank you, everybody. So if you have some questions, please raise your hand. Sorry?
Can I talk to you for a minute after you?
Okay, no problem.
So in the interest of time, let's go ahead and hold our questions till the end, and let's go ahead and thank our speaker.